Okay, so this will be the quadratic surface meant to be on calculus for class A and class B. But this is actually a recording of class B because they have no sound at the first video. So I will make out this audio for the chapter 12.6. So this will be the quadratic surface. So after you learn about the cylinders and how they are or how to create the surface on some curve, like for here we have the z equal x squared, we have the quadratic, and we have the other x squared plus y squared equal 1 and y squared plus z squared equal 1. We can make out a cylinder out of those questions. So the idea behind of this drawing is we are looking at different perspective on each plane, xz, yz, and xy, and by simply taking sometimes to imagine how it looks like from isometric views, we can take it into our graph. So this will be z, so this will be our reference line to draw the cylinder. And this reference line can be obtained from the equations as z equals 0, that is our reference line, and the second one having the x-axis as reference line, or x equals 0. Okay, now we are moving to drawing the quadratic surface. So what's the quadratic surface means? Okay, so ideally, the quadratic surface means that the surface that we can shape out of the second degree of our equations. So we can say it's a graph of second degree equations in 3 variables. Okay, so we can write these surfaces into the general equation. So we will write down listed all the terms for x, y, z that has the highest degree will be the second degree. So x squared plus by squared plus c z squared, and then all the combinations for xy, xz, and yz. And the rest will be the linear x, y, z, and also we will have a constant. Okay, plus the gx, and then plus hy, and then plus the j, az, and then j. Okay, now from the look of it, we can think this as if we have at least some of these components from this general equation, we can make sure that what we are dealing with is our the quadratic surfaces. We can say that this a, b, c until j is our constant. Okay, now if we take the quadratic surface, we can shape this into or we can say that this is a counterpart of the conic sections, and I hope you still remember the type of conic sections. We have at least 3 types, right? So we have the ellipse, we have the hyperbola, and we have the parabola. Okay. Now we can write some of these conics. Okay, first we can write the ellipse. Okay, and then you see that we have x squared plus y squared. Okay. And we have the constant a and b, in which we are going to have the major axis in which one x or y, right? And we have the hyperbola, that is the if we have x squared minus y squared, or y squared minus x squared, and it depends on which one that having the opposite sign, and that will be determine how the hyperbola will be. Okay, it's top down or left right. And parabola, well, parabola means that parabola on conic sections will be related to its geometric sections. We can have y squared for px and x squared for py, right? Okay, we take some example on how we can trace some of the equations and sketch the quadratic surface. Okay, let's start with this. We have x squared plus y squared over 9 and z squared over 4 equal 1. Okay, what's the idea behind this question? So this example shows us that all the terms having plus signs, right? So first, what we can do is we can trace the surface by taking each variable becoming constant or becoming a 0. Okay. Now let's take the z equal 0, and what we have. We will have the x squared and y squared over 9. And this will determine that it will be an ellipse. So if we look on the xy plane, we will see an ellipse, okay? Okay, if we take this equal a constant, you will see that we will have the xy plane. So we will still have an ellipse in the xy plane, but we will have a different height with different height. So we are kind of shifted our ellipse upside or downside. Okay, now if we let x equal k, we will see that we have the yz plane. Okay, we have the ellipse, same ellipse on yz plane. Okay. Okay, same thing with the y equal k. We will have xz plane that has an ellipse. So we will have 3 ellipses on 3 different planes. Okay, so if we imagine that an ellipse can be shifted for each ellipse, we can shift it. We move out through a different height. Then we will have a shape that is restrained by an ellipse in all 3 different planes. Okay, now we check the sketch. Okay, so let's draw the 3D space. So x, y, z for 3D space, and we will draw all the ellipses. Okay, all the ellipses. So we start. Let me use different color. Okay. Okay, we start by drawing the xy plane, so the ellipse on xy plane. It has x equal 1 and y equal plus minus 3 for the size for each axis, for the major axis and minor axis. But the first ellipse we have done. Okay, we take the other ellipse, the xy plane. Okay, now the yz plane, we also draw the ellipse. And then imagine if we connect all these three ellipses will be restrained in all sides, and we will have a shape of a ball in the American football, right? In the American football, you see an image of a picture like this shape, and we call this the ellipsoid. So ellipsoid will be having all traces in ellipse, okay, in ellipses. Okay, if we illustrate how the ellipse will trace, at least from this xy plane, this will the tracing. Okay, so we will have a different height and then different length in the axis for the ellipse, right? Okay. Okay, we take another example. 4x squared plus y squared okay, what will happen in this quadratic surface? Well, we'll see we have at least an ellipse if you take z equal 1, and the other two will be a parabola, right? Z equal 4x squared and z equal y squared. Okay, now if we take each equations and we observe, okay, so we have the parabola, right? Two parabola. Okay, we take the 3D space and let's see how our parabola looks like. Okay, let's start with the YZ plane. Okay, YZ plane, the parabola, z equal y squared. That's the parabola. And the other one is on XZ plane. That's the blue one. Okay, we have two parabola now. Okay, we make some adjustment on the drawing to make easier to observe and analyze. Okay, now we observe the ellipse. Okay. So when we have z equal 1, we will have an xy plane. that's our ellipse. Here we can draw the ellipse. Okay, now we call this shape as elliptic paraboloid. So elliptic means it will be the boundary. The ellipse is the boundary of two parabola. Okay, now if we look on the reference, I think this is to make sure that our drawing is correct. Okay? So the first one is the ellipsoid, the second one is the elliptic paraboloid. Okay? So as you can see, that's our drawing, and this is the reference. Okay, we have the third example, and I think this is the most difficult one. We have z equal y squared minus x squared. Okay, we take some approach here. So first we trace the z equal k. So we are going to look on the hyperbola, right? Hyperbola form structure. Okay, now we take some observation on the other two plane, and we have the parabola for yz plane, and for xz plane we have parabola. Okay, we have the parabola, then, and because of the parabola having the minus, then it will be upside down. And now if we look on the hyperbola, if we take this as the constant as -1 or 1, we will have two sides. It's either the left, right, or top, down, right? We can exchange y and x having the negative signs. Okay. Okay, we observe the parabola. Okay, we take the parabola first, and how we are going to have some behavior on the curve. Okay, we have the positive parabola for just a regular y squared, right? So let's draw. Okay, now we sketch the quadratic equations. So this is the parabola, And if we take a constant -1 or 1 for the k, because it's a quadratic, you have the same results, and it will be shifted downwards, right? Shifted downwards. So we'll have a parabola that is going to have downwards like this for -1, and also the same downwards on when x is equal 1. Okay. Okay, now we are looking on the second parabola, and it will be the upside down parabola. Okay, now same thing. If we take the y, maybe take y equal 1 or y -1, we will have a parabola that is shifted upwards. So we are going to see the vertex is moving upwards. Okay, and then we have these two parabola now. We have the parabola for the left one and the right one. And if you see the connections, it's actually the vertex on each parabola is all connected. Okay, it's all connected. Okay, so you can imagine if you connect all the points on the vertex, they are you can see that it's a connecting. Okay. And let's observe the hyperbola. This is difficult. So first we can take the k as -1 and +1. Okay, and if we take the sketch, then we will have the hyperbola for y² minus x² having two equations. So first is y² minus x² equal 1. It's just the usual hyperbola. The second one is y² minus x² equal -1, or we can exchange the signs and becoming x² minus y² equal 1. Okay, now if we take z equal 1, and then we can make out the hyperbola because it's on y² minus x² equal 1. So this will be an top-down hyperbola. Okay, so you can confirm all these drawings if you are looking from the xy plane. Okay, you can look from the top and see how it looks like. And second one, we draw the second hyperbola for -1. This is the we have the left right now, the x² minus y² equal 1, or y² minus x² equal -1. if we are looking from the xy plane, this is how it looks like. Okay, so we have the top down and left right hyperbola. Okay. Now we need to combine all the parabola and the hyperbola. It's quite complicated. So first we need to imagine the two parabola is connecting, right? And the hyperbola will be the boundary for the sides, for each sides, for each plane. Okay. Okay, now we are taking the parabola to get our first look. Okay, now let me draw the whole thing first, and let's see how we are looking at the hyperbola. Now we have the hyperbola. Look at on the sides. This is the hyperbola for top down for xy. Okay, now we connecting all the point. Okay, and then the left, on the left is the hyperbola. This is the other one. Sorry. So yeah, let me draw this. Okay, I hope it can be observed very well. Okay. Let me adjust this, and you will see that it's connecting. Okay, and then if we are going to make sure, confirm that this is our parabola, and this is also the other hyperbola. Okay, now we are looking at the like a saddle, actually, like a saddle when you are riding a horse. Okay, maybe you remember when riding a horse, if you experienced that when you're still a child, because I have experience riding a horse. And of course, when you are riding a horse, you need to the horse need to be equipped by the saddle, and it is the same structure as what we have in our graphs in our drawing in the above picture, right? And the point here at the origin in our saddle is called the saddle point, and we will learn more on saddle point later on chapter 14, and we will observe how we can achieve this saddle point in the partial derivatives. Okay, we can also call this shape as the hyperbolic paraboloid. Okay, example for the other shape. Let's look on these equations. We have x squared over 4 plus y squared minus z squared over 4 equal 1. And we are going to see that we have an ellipse, we have an hyperbola, right? And we need to trace the equations and we can sketch the shape. Okay, we are looking at the hyperbola. Okay, so this is hyperbola, and the other part, also the other hyperbola, we can write down the equations. Okay, now we have the other one as the ellipse. Okay, now we are going to have this hyperbola if we are taking the yz plane. Okay, so we have the top down on yz. Okay, let's draw. Okay, now we have the other side for the xz plane. Okay. Okay, let me adjust the curve so it will be more better. Okay, we can, I think we are starting to using the ellipse to make it I think easier to draw. So drawing the ellipse on each point, and all the hyperbola will be bounded on the sides of this ellipse. Yeah, I hope it can be clearly seen that it has like a shape on, I don't know if you are visualizing, it's like a reactor. If you see one, if you have seen one reactor, it's like that. We call this shape as hyperboloid of one sheath. Okay, let me put the actual reference for the saddle, the hyperbolic paraboloid and also the hyperboloid, to make sure that we can clearly see the graph. Okay. Okay, the other example. Okay, if you see this example is the structure is similar with the previous one, but the difference is we have two negative signs. Okay. Okay, we start the tracing and write down all the equations. So first one is we have the hyperbola for z equals 0 if we take the tracing. The other one will be x equals 0. So this is another hyperbola. So we have two hyperbola. And also the last one we have the y equals 0, in which we have the ellipse. Okay, now we have x squared plus z squared equal over 2 equal k squared over 4 minus 1, and we now clearly see that this is the ellipse. Okay. Okay, now we trace the hyperbola. Okay, first y squared and the x squared. So of course it's going to be top-down hyperbola, okay, for y and x, and the other one y and z. We also see the y, because it's the positive one, it will be the top-down. Okay. Okay, now the rest will be an ellipse. We will have the ellipse in boundary, and because of the hyperbola crossing each other, we will separate these two shapes, and this is not in one shape, and we call this hyperboloid two shape. Okay, so it's the previous one is called one shade, and this is two shades. It's because it's having two sides of geometric sections. Okay, let's take some time to summarize. Okay. Summarize all the quadratic surface that we have learned. Okay, we have 6. First is ellipsoid, elliptical paraboloid, hyperbolic paraboloid. We have also the cone, we have the ellipse, and if we trace the cone, we have the plane x equal k and y equal k. So we can see how all the surface has each own unique property represented in the equations. Okay, and we also need to at least see each property, okay, for each quadratic surface. So for example, this hyperbolic paraboloid, it has the one linear and two quadratic, but it has different signs for the quadratic. Okay, and we know that this will be the hyperbolic paraboloid. So next time you see the equations, you can determine or you can identify which quadratic surface this equation is. Okay, now yeah, the cone having all quadratic forms, but one will be on the other side as this determine the axis. And we'll have the hyperbolic one sheet. We have two positive signs, one negative signs. Okay, and the negative signs will be the axis. Okay, it will be the axis. And then the hyperbolic 2 sheet, it has two negative signs and one positive signs. Okay, and I think we can move on from this summary. And as long as you know how to identify the quadratic surface, I think that should be fine. Okay, let's try some example. Okay, this is how to classify the surface and then sketching the surface. Okay, so let's write some equations and determine the surface and sketch. So first, you can try to simplify the form. Okay, we group all the variables into each one, and we can solve it. Okay, and then the other questions, number B. Okay, now this other question is the B. Okay, number B. Okay, let's try to solve it. Okay, let's solve. I think number B is easier, so let's take all number B first. Okay, we can write the equation as y equal 4x squared plus 2z squared, and we know that this is going to be elliptic paraboloid. Okay, this is if we divide all by 4, and we can take time to imagine that it's going to be an ellipse, okay, with x squared plus z squared over 4, and also the parabola for y equal x squared and y equal z squared. Okay. Okay, let's draw this. Okay. So because y will be our axis, so I will try to make y axis a little bit longer. Okay, Okay, let's make it into this equations, and this is the other parabola, and this is how it looks like. Okay, we try to grouping for each variable for number A. Okay, we are using complete standard form. We try to simplify. Okay. Okay, now we have this equations, and it means that if we have this kind of equation, this means that we are moving the at least the center, okay, or the vertex if it's parabola. So we'll have the center or the vertex moving from 0, 0, 0 to 0 and 1. And then we can sketch the graph. Let's try to make it into our graph. This is the sketch. So we will have the ellipse and then the hyperbola. Okay. Okay. So let's try to adjust the hyperbola. So we'll have the hyperboloid of one sheet. Okay. And I think that will be our conclusions for today's sessions. And yeah, I forgot to write that, to mention this is the center. Okay, so yeah, this is actually the re-recording because previously it has no sound, and hopefully it can help you to understand better for the content. Okay, see you next time.